Greetings and hi, my name is Farah Shahira binti Kamal Azmil. In this video, our group is going to present the Newton's law of motion for this experiment 2 in this course Physics 110. Now let's proceed to the next slide. Before we get into the experiment, I am going to introduce myself and the other group members. My name is Farah Shahira binti Kamal Azmil. For the second member is that Nur Adrenna binti Mohamad Ali. The third member is Mirza Elyana binti Mohammad Mahathir. And the fourth member is Nur Faieza binti Abu Bakar. We are all from the class AS1201E. Now, for the table of contents, it consists of objective, procedure, results, analysis, and conclusion. In this experiment, I am going to present the objective and the conclusion, while Mirza Elyana is going to present the procedure and Nur Adrenna is going to present the results, and last but not least, Faieza is going to present the analysis. For the objectives of this experiment, first, it is to investigate the relationship between total forces acted on an object with acceleration of the object. And secondly, to study the Newton's second law of motion.
The procedures are divided into two parts, which are non-friction surface and friction surface. For non-friction surface, first of all, the force graph tab is click. The second one is the parameter setting is set as object, small crate, friction, ice, no friction, and acceleration graph is added by click on this acceleration button. The force applied is set to 500 Newton for the first data, then play button is pressed to begin. After that, the acceleration is recorded. The results are tabulated in table 1. Reset all button is clicked for a second reading. Above steps are repeated at least 3 times for each data, and step 2 until 7 are repeated for another 9 data. For friction surface, first of all, the force graph tab is clicked. Secondly, the parameter setting is set as object, small crane, friction, wood, and acceleration graph is added by click on this acceleration button. Then, the force applied is set to 500 Newton for the first data, and play button is pressed to begin. After that, the acceleration is recorded. The results are tabulated in table 2. Reset all button is clicked for second reading. Above steps are repeated at least 3 times for each data. Lastly, step 2 until 7 are repeated for another 9 data.
Moving on to the result. For the non-friction surface, which is ice, we use the applied force of 500 Newton until 1400 Newton. As for the friction force, the friction force is equal to 0 as ice do not have friction. So the total force is actually equal to the applied force, as you can see here in this table. When the total force is 500 Newton, the acceleration will be 5, and when the total force is 600, the acceleration will be 6. As you can see here, the pattern is increasing. As the total force increases, the acceleration will be increases too. So next, we will be moving on to the friction surface, which is wood. So we use the same amount of applied force, which is 500 Newton until 1400 Newton. So the friction force of a wood is equal to negative 294. So as you can see here in this table, the total force is equal to the applied force plus the friction force. When the applied force is 500 Newton, and the friction force is negative 294, the total force is equal to 206. when the total force is equal to 206, the acceleration would be 2.06. As you can see here in this table, the pattern also increases. As the total force increases, the acceleration would be increases too.
For the experiment, question number 1, from the data, plot graph for a total force as a function of acceleration for a non-friction surface. So this is the graph. We put the total force at y-axis and the acceleration at x-axis of the graph. For the second graph, we have to plot the graph of total force as a function of acceleration for friction surface. Basically, the graph is the same. We put the total force at y-axis and the acceleration at x-axis. The difference is just the data of the graph. So moving on to the next question, question number 2. From both graphs, state the relationship between the total force with the acceleration of the object. So the answer is, from graph 1a and graph 1b, the total force is directly proportional to the acceleration and do increase linearly. Next question is, does the graph obey Newton's second law of motion? Explain. So yes, the graph obeys the Newton's second law of motion. According to Newton's second law of motion, the acceleration of an object depends to two variables, which is the net force acting on the object and the mass of the object. The acceleration of the object increases as the force acting on the object is increased. The acceleration of an object decreases as the mass of the object increases, thus making Newton's second law of motion accelerated proportional to force while inversely proportional to mass, F equal to ma. For question number 4, determine the gradient or the slope of the graph. What do the gradients represent and explain? For this question, we use the gradient formula, which is m equal to y2 minus y1 over x2 minus x1. For graph A, the gradient is 1400 minus 500 over 14 minus 5 is equal to 100. So the gradient is 100. For graph B, 1106 minus 206 over 11.06 minus 2.06, the gradient is also 100. So the gradient represents the mass of the object. This is because Newton's second law of motion states that the acceleration is directly proportional to the net force. However, the slope of both graphs show that the acceleration is inversely proportional to the net force, F equal to ma. So the gradient represents the mass of the object. For the last question, using Newton's second law of motion, prove that the coefficient of kinetic friction between the small crack and the wood surface is 0.3. So the formula for kinetic friction is Fk over n, where Fk is friction force and n is the normal force. So we use the formula F equal to mg to find the normal force, and the Fk is 294. Thus, to find the kinetic friction, we use the formula 294 over 1000 is equal to 0.3. So the coefficient of the kinetic friction is proved.
Now, for the last part of this presentation is the conclusion. Based on the result of this experiment, it is safe to conclude that the main objective of this experiment, which is to investigate the relationship between total forces acted on an object with acceleration of the object and to study the Newton's second law of motion, is successfully conducted. According to Newton's second law of motion, it is stated that the acceleration of an object is directly proportional to the net force and is inversely proportional to its mass. Hence, as the total force increases, the acceleration increases as well. This statement can be proved from the graph that is shown from the analysis. Furthermore, this experiment also consists of two different surfaces of frictions, which is the non-friction surface that is made from ice and the friction surface that is made from wood. The presence of friction in this experiment is to show that the friction is presented in the Newton's second law. The total mass of an object that is used can be obtained from the gradient of the graph. In addition, this experiment can also be improved by using variance of friction for further result. Therefore, this experiment is complement to the Newton's second law. That's all from our presentation. Thank you for watching.